Hi, let's take a look at section 2.3, where we're looking at linear functions and slope. The slope-intercept form of the equation of the line is written as y equals mx plus b, where m equals the slope of the line and b is the y-coordinate of the y-intercept. If 2 points, one with coordinates x1, y1, the other with coordinates x2, y2, are given for a non-vertical line, the slope, which we'll use a lowercase m to represent, can be found by the formula y2 minus y1 equals x2 minus x1. This is also called the rise over the run. The rise is actually the change in the y coordinates of the line. The run is the change in the x coordinates of the line. Sometimes this is referred to as the vertical change compared to the horizontal change. All points that lie on the same horizontal line have the same y coordinate. All horizontal lines have an equation of the form y equal b, where b is going to be some constant, some fixed number. The slope of a horizontal line is always 0. All points that lie on the same vertical line have the same x-coordinate. All vertical lines have an equation of the form x equal a, where a is some fixed constant. The slope of a vertical line is always undefined. The point-slope form of the equation of a line is written as y minus y1 equals m, the slope, times x minus x1, where x1, y1 is a point on the line and m is the line slope. So let's look at some problems in this section, some of the exercises that you'll find in your homework. I want to find the slope of a line passing through the given 2 points, and I want to indicate whether the line through the points rises, falls, is horizontal, or is vertical. I'll label the points as x1, y1, that's the first point, and the second point is x2, y2. It actually doesn't matter which point you call x1, y1, or which point you call x2, y2. So we know the slope, lowercase m, is y2 minus y1 divided by the difference x2 minus x1. So in this case, x2 is 6 and y2 is 3. And x1 is negative 5, y1 is 6. So I put those numbers in their appropriate places. And when I carry out the operations, I wind up with the slope is negative 3 over 11. So I select A. I'll type, when I'm in my math lab, I'll type negative 3 over 11 in the box. And then I'll also have to determine whether or not the line rises or falls. Whenever the slope is negative, the line through the points falls. So a negative slope corresponds to a falling line. Let's take a look at number 5 from this section, where I'm doing the same thing. I'm finding the slope of the line through the 2 given points, and then I'm going to indicate whether the line rises, falls, is horizontal, or is vertical. And notice this time I'm going to label the first point as x2, y2 and the second point as x1, y1. It doesn't matter which point I label. But notice what matters is when I put a y in the numerator first, its x has to be first in the subtraction in the denominator. And in this case, I wind up with 0 over 6, which simplifies to 0. So I select A, the slope of the line is 0. And I want to make sure any answer I give is in simplified form. So the line through the 2 points is horizontal, because horizontal lines are the only lines that have a slope of 0. Now let's do the same thing again for 2 more points. This time I'm going to label the first point as x1, y1, and the second point as x2, y2. When I go to find the slope, what matters is whatever y is first, the x that goes with that y is first in the denominator subtraction. So whatever y I put first in the numerator subtraction, I have to make sure I put the x that goes with that y first in the denominator subtraction. And also, when you're subtracting a negative, make sure that you subtract. In the denominator, I have negative 7 minus negative 9. You wouldn't want to write that as negative 7 minus 9. And notice that actually changes to the addition, negative 7 plus 9, which is 2. So my slope is 1. Whenever my slope is positive, my line rises. So the line through the points rises. A positive slope means the line rises. So we want to work the same problem for two different points, negative 5, 3 and negative 5, 9. This time I'm labeling the first point as x2, y2, the second one as x1, y1. What matters is if I put 3 first in the numerator, the negative 5 that is paired with it has to be first in the subtraction in the denominator. And again, I want to be careful that when I subtract a negative, that's what I do, and that will always turn into addition of a positive. So I get negative 6 over 0. Division by 0 is always undefined. So this slope is undefined. I choose B. The line that passes through the points is vertical. The vertical line is the only line that has an undefined slope. So the line that passes through these 2 points is vertical. All right, let's go to the next problem. And this is number 11. And here we're doing something different. We want to write the point slope form of the line equation satisfying the conditions. The slope is 2, so that means our m is 2. And if the line passes through the point 6, 7. So our x1 is 6 and our y1 is 7. And remember that the point slope form of a line the point slope equation of a line has the formula y minus y1 equals m times x minus x1. And notice that for this situation, that gives y minus 7 equals 2 times the difference, x minus 6. So this would be the point slope form of the line equation. And an important thing to note about this form isn't unique. Because a line has infinitely many points, you could have any other point in place of the point 6, 7 that lies on the line. So if we solve this for y, we'll obtain the slope-intercept form of the line equation. So first I distribute the 2. 2 times the difference x minus 6 is 2x minus 12. I multiply the 2 times the x and times the minus 6. I'm going to add 7 to both sides to isolate the y, and I get y equals 2x minus 5. So this is the slope-intercept form of the line equation. And one important thing about this is unique. There's one and only one slope-intercept form of a line's equation. there are many forms of the point slope equation. If you pick a new point, you're going to see a new point slope equation, as long as it's a point that passes through that line. All right, so here we're given 2 points, and we want to find the point slope form and the slope intercept form of the line equation. So the first thing we're going to do is find the line slope. So remember, lowercase m represents slope, and I find that by subtracting y1 from y2 and dividing that by the difference x2 minus x1. All right, so it doesn't matter which point I call x1, y1, which point I call x2, y2. But notice if I put the 5 first in the numerator, the 2 that goes with it has to be first in the denominator. And 5 minus negative 5 is 5 plus 5. 2 minus negative 3 is 2 plus 3. So I get 10 divided by 5, which is 2. So my slope is 2. So I'm going to let m equal 2, and x1 can be either of the x's. Since I chose x1 equal to 2, I have to therefore choose y1 equal to 5. I have to choose the y that goes with the x that I've selected. But it doesn't matter which point I use. I chose the point 2, 5 because I'd rather work with positive coordinates than negative coordinates. So remember, the point slope equation is y minus y1 equals m times the difference x minus x1. So for this problem, that's y minus 5 equals 2 times the difference x minus 2. I'm going to distribute, and I get y minus 5 equals 2x minus 4. And if I solve this for y, I will then have the slope-intercept form of the line equation. So when I add 5 to both sides, the left side becomes y, the right side becomes 2x plus 1. So the first equation, where I filled in the values, was the point slope form of the line equation. The final equation is the slope-intercept form of the line equation. And notice, if you had used the other point, you would have gotten a different point slope form, but it still would have been correct. All right, now I want to use the fact that this new line for number 35 passes through the point 5, 2 and has an x-intercept of 2. So I want to use that to find the point slope and the slope-intercept form of the line equations. All right, so the line's x-intercept is 2, means that 2, 0 is a point on the line. So whenever I'm on the x-intercept, the y-coordinate is 0. So we now have 2 points through which the line passes. It passes through the point 5, 2, which was given. And now we also know, because we understand what the x-intercept means, that it passes through the point 2, 0 also. So we're going to use, the second thing we're going to do is use these 2 points to find the line slope. So the slope is y2 minus y1 over x2 minus x1. So I'm going to let x2, y2 be the point 5, 2. So I put the 2 first in the numerator, then the 5 that corresponds with it as x has to be first in the denominator. And I put the 0 of the second point second in the subtraction in the numerator. So underneath it has to be its 2. That point had a x-coordinate of 2. So 2 minus 0 over 5 minus 2 gives me a slope of 2/3. So now I'm going to write the point slope equation for the line. So remember, m is 2/3, and I'm going to let x1 be 2 and y1 be 0. That's the easiest point to work with, so that's the point that I'm going to use. So y minus y1 is y minus 0. M times the difference x minus x1 is 2/3 times the difference x minus 2. y minus 0 is just y. 2/3 times x minus 2 is 2/3 x minus 2/3 times 2. And so 2/3 times 2 is the same as 2/3 times 2 over 1. So 2/3 times 2 over 1 is 4/3. So I get y equals 2/3 x minus 4/3. So let me move things down here a little bit. And I want to identify the point slope line equation. And so y minus 0 equals 2/3 times x, the quantity x minus 2, is the point slope form of the line equation. Remember, that would have looked different if I would have used the other point. But I always choose the easiest point to work with. So if we solve that equation for y as we did, we'll get the slope-intercept form of the line's equation. And so we see that this final equation is the slope-intercept form of the line's equation. And that's unique. There's one and only one form of the slope-intercept form of the equation. So now let's look at problem 69, where we want to use the intercepts to graph the line 5x plus 2y plus 10 equals 0. So this is the general form of the line equation. Now, one thing you have to be careful of on a problem like this, you have to make sure that you graph the line using the intercepts if that's what you were instructed to do. So I find the y-intercept by letting x equals 0 and solving for y. So I go into the equation and I replace x with 0. So instead of 5x, I have 5 times 0 plus 2y plus 10 equals 0. And I'm going to solve this for y. So 5 times 0 is 0, so that's just going to drop out of this. I'm going to subtract 10 from both sides, and I now have 2y equal negative 10. And now I'm going to divide both sides of the equation by 2 in order to solve for y, which is negative 5. So this means 0, negative 5 is the y-intercept of the line. And now I need to find the x-intercept. So I'm going to do that by letting y equal to 0 and solving for x. So wherever I see a y, I'm going to replace that with 0. So instead of writing 2y, I write 2 times 0. And that's going to drop out of the problem. I'm going to subtract 10 again from both sides of the equation. And now I have 5x equal negative 10. I'm going to divide both sides by 5 to isolate x. And I get that x is negative 2. So negative 2, 0 is the x-intercept of the line. And if you graph this equation, if you graph the line by using any other points other than the two x-intercepts, then the answer is going to be marked as wrong. So you want to make sure you follow the instructions. So we're going to plot these 2 points, 0, negative 5, and negative 2, 0. So we would select the line tool. If you were in my math lab, you'll select the line tool and you'll plot the first point, which negative 2, 0 lies on the x-axis. That's the x-intercept. 0, negative 5 lies on the y-axis. That's the y-intercept. And then my math lab, as you're plotting the points, will automatically put the line through the 2 points that you plot. And as long as you use the 2 intercepts and you got those 2 intercepts, the point will be correct. Here we're given the slope-intercept form of a line's equation, and we're asked to find the slope. Well, the slope is always, if y is isolated on one side of the equation and the other side is simplified, and the line's not vertical, y, the coefficient of x is the slope. So in this case, that's negative 1/8. And the constant is the y-intercept. In this case, that's 4. So what we're going to do is first we're going to plot the point 0, 4. And remember, that's the y-intercept. So that lies on the y-axis, and I plot a point there. Second, I'm going to use the slope to move from that point to another point on the line. So the slope is negative 1/8. So I can think of that as negative 1/8. If I do, that means I'm moving 1 unit down from the y-intercept and then 8 units right to get to a second point on the line. And that would land me at the point that I've indicated. I also could think of this as 1/-8. It's another correct way to think of this, which means from the y-intercept, I would move 1 unit up and then 8 units left. And that gives me a different point, but it's still a point on the given line. And notice how both of those points lie on the line. So you can do either movement to get a second point